final project in AFTE 115 Antenna Fundamentals, we were tasked to create our very own dipole antenna design. Let's start by defining a dipole antenna design. Two conducting components aligned symmetrically make up the basic and effective dipole antenna design. Usually, a transmission line is linked to the center point of the dipole arms. The resonant length of this balanced antenna is half the wavelength of the intended frequency. It may be positioned vertically or horizontally to produce various radiation patterns. Considering their overall performance, wide bandwidth, and ease of fabrication, antenna dipoles are frequently employed in wireless communication, broadcasting, and amateur radio applications.
The given measurement to us is F31D with a measure of 10 to 300. The given measurement to us is. We will begin with center frequency. The center frequency, the midway or average frequency of a signal, is crucial in the frequency domain for filtering, modulation, demodulation, and signal processing, as it often linked to the carrier frequency, the primary frequency used in communications. Let us now input our given measurements. The square root of 10 times 10 raised to 6 megahertz multiplied by 300 times 10 raised to 6 megahertz. The answer we will come up with is a square root of 3 times 10 raised to 15 hertz squared. The final answer is 5477255.75 hertz.
Moving forward to wavelength. Wavelength, denoted by lambda, is the distance between two crests or trough in a wave. Determining its spatial expanse, it is inversely proportional to the wave's frequency, with shorter wavelengths corresponding to higher frequency and vice versa. And its formula is C divided by Fc, or center frequency. Let's begin. The value of speed of light is 3 multiplied by 10 raised to 8 meters per second is divided by 5477255.75 hertz is equal to 5.477255.75. This answer will then be multiplied to 0.94, and our final answer is 5.148592041 meters.
Its formula is C divided by Fc, or center frequency. Let's begin. The value of speed of light is 3 multiplied by 10 raised to 8 meters per second is divided by 5477255.75 hertz is equal to 5.4772255.75. This answer will then be multiplied to 0.94. Our final answer is 5.148592041 meters. An antenna's driven element is a part that transforms electric impulses into electromagnetic waves, or the other way around. It is frequently linked to the feed line or transmission line and is made to efficiently emit or receive electromagnetic radiation. The radiation pattern, gain, bandwidth, impedance matching, and overall performance of the antenna system are all strongly impacted by the driven element's performance. For the formula of the length of the driven element, we have wavelength divided by 2. Let's input our values. 5.148592041 meters divided by 2 is equal to 2.5742960 meters. A director is a component in an antenna design that enhances the radiation pattern and gains in a specific direction. Positioned in front of the driven element, it directs electromagnetic energy, improving directivity and signal reception. The number and spacing of director elements can be adjusted to achieve desired radiation characteristics and beam width.
The formula to use to get the length of the director is the length of the driven element minus 5% of its length, or 0.95 multiplied by the length of the driven element. Inputting our values, we have 0.95 multiplied to 2.57429602 meters is equal to 2.445581219 meters.
Now we have reflector. Redirecting electromagnetic waves emitted by the driven element is done by a larger part of the antenna design, called a reflector, which is placed behind the driven element by concentrating radiation in the intended direction and decreasing radiation in other directions. It increases the antenna's directivity and boosts gain, signal reception, and transmission efficiency.
Formula is the length of the driven element plus 5% of its length, or 1.05 multiplied by the length of the driven element. Inputting our values, we have 1.05 multiplied to 2.57429602 meters is equals to 2.703010821 meters. Next, we have the spacing from reflector to driven element. The formula for this is 0.15 multiplied to wavelength. So we have 0.15 multiplied to 5.148592041 meters. The answer we will have is 0.7722888 meters.
Moving on to spacing from driven element to director. The formula is 0.10 multiplied to wavelength. So we have 0.10 multiplied by 5.148592041 meters. The answer is 0.5148592041 meters.
A boom is a long rigid structure supporting antenna array components, typically metal or non-conductive. It provides mechanical stability, maintains element positions, and aids in achieving desired radiation pattern and performance, ensuring the desired spacing between.
To solve this, we have the formula spacing from reflector to driven element plus spacing from driven element to director plus 0.0508. The final answer is 1.33794801 meters.